Hello, everyone. Thanks for joining us. Um, Thank you, Catalina and Chris, for joining us today, and looking forward to your presentation. Um, we have Catalina Herrera and Chris Helmus from Dataiku, who are going to present about de-risk your AI efforts by removing friction from your MLOps processes. A brief introduction about our speakers today. Catalina Herrera is a principal sales engineer. She has a passion for data and
Sure.
analytics. Catalina has spent her entire career helping the industry push beyond digitalization to business transformation. She's held both educational and technical positions and worked with state of art technology solutions across multiple industry verticals and served as data scientist and advanced analytics consultant. Today, Catalina works with Fortune 100 companies and global technology leaders on digital transformation initiatives. Chris is also a senior sales engineer at Dataiku. Chris has spent his career helping people and organizations embrace self service analytics and machine learning. His expertise spans from enabling business users to become data experts to MLOps at scale with a focus on enabling collaboration. When he's not working with data, you can find Chris at music events in Denver area. Um, we are good to start the presentation. Over to Chris and Catalina. The audience can post any questions that they have in the chat, which you can take maybe after the session if you'd like.
Awesome. Thank you. Can I have a verbal as in yes, the screen is showing?
Yes, the screen is visible.
Perfect. Perfect. So welcome to this session. Today we will talk about MLOps, which is what is that machine learning operationalization, which means what are we going to do with these models that we are creating? You, your team, your people. So I will walk you through a machine learning pipeline process. We're going to be highlighting different team members' contributions and, oh, me?
Yeah, you might want to just, because we lost you for like 3 seconds, you might just want to pop off.
So I will walk you, let's recap. Welcome to this session, everybody, and glad you are here. This has been a great event. I have been monitoring some of the questions, some of the chats, very good interaction here. So today we will talk about MLOps, which means machine learning operationalization. That translates into what do you do with those machine learning models that you or your team are producing, right? So I will talk you a machine learning pipeline process. We're going to start from the beginning all the way to the end. We're going to highlight the different team members' contributions, the pros, the cons, what's going on today in the industry. And we will connect all the dots at the end so you can see what it means to deploy a machine learning model. And hopefully at the end, we're going to highlight the Dataiku's governance framework that is going to help you, connect all the dots as in how Dataiku can help you removing the friction from your MLOps processes. So realistically, every organization wants to scale with AI. And in general, we are all targeting the same, like better customer experience, improve employee productivity, accelerate innovation. And I believe that as a community, and when I say as a community, us, the data scientists, the analysts, the digital transformation leaders, us, the community, we know the power of data. In fact, metrics like increasing process efficiency by 10 or so should not really surprise. However, this is not an easy thing. It's not so easy to accomplish. And we think about the whys. Why? What's going on? What's going on behind the scenes? So there is still a lot of a struggle when thinking about scaling with AI, because AI is analytics, is data science, is what we do on top of that data. And it has absolutely no sense if we are not connecting our people, the technology, and those processes. right? So where is this struggle coming from? Well, connecting these people, technology, and processes can be challenging. And if we have an overview of an analytics process, and I'm gonna highlight a couple of things here, because there is a lot involved when we are trying to make the most out of this data. So for an analytics process to start, we should have the business problem that we are trying to solve as a starting point. What is it that we are trying to solve? What is that use case that we are putting this team efforts into? How are we going to represent that use case with the data that we have? Where is that data coming from? How many silos can be part of that data? And how are you going to ensure that you are manipulating or transforming that data and understanding that data in a way that you ensure that your business use case is being represented? So in a normal analytics process, you're going to see different stages. Stage one is going to be, okay, how are we going to represent that business use case? That usually is ingesting data from different silos. We have different companies using different infrastructures where you have these silos of data. You may have an on-prem data source solution. You may have a cloud data solution. You may have a hybrid infrastructure solution where some of your data sources are coming from A, some others are coming from B, some others are coming from C. Some of the data structures are regular columns and rows that is called structured data, where you can actually start working right away with it. But a lot of it can be also unstructured data, where you actually have a lot of information that complements that business use case, and that is still kind of part of that process that is rarely linear. So the black arrows are telling you, okay, I can go from the business understanding to knowing what kind of data is behind this use case. And then I can go to, okay, what do I have to do to consume this data? How I need to clean it, or how are going to ensure the good quality of the data so I can start moving into a solutions building stage. Oh, the red arrows here are representing what really goes on in this process, right? And we mentioned this is rarely linear. And it means that it's usually a feedback that is involved by default. Why? Because we are working together as a team and as an extended team. And perhaps we're thinking about different perspectives, different daily tasks, different responsibilities. And that makes it very important because we are going to be consuming this data, making the most out of it, but at the same time, ensuring that we can collaborate with the extended team as every data scientist without that SME, without that subject matter expert. And a lot of these guys are not necessarily coders or data scientists or Python R coders, right? So what needs to happen for us to still ensure that we can make the most out of that data, understand that business use case, represent it, ensure that we have the data represented in the best possible way. Therefore, we can move into a solution building stage. And that solution building stage has to be validated by our subject matter expert. Is this thing doing what we think it should be doing? Do I have an outlier that is very obvious? Do I have the real representation of my problem within the sample, right? Can I start seeing some correlations and patterns that are actually in alignment with my expertise? And here is when we start having issues in today's solutions. And this is what we see in the industry today. What's going on today in the industry? Well, we understand that we have to go through a cycle. We know that it's usually a stage one, building that model. And you may have a completely different set of personas here thinking about the different stages of this cycle. So let's wear different hats here, and let's think about as the data scientists that we are and as the analysts that we are. But today, let's think about the responsibilities from some other members of the team so we can see how important it is for us to be able to collaborate. So when we are thinking about these data science projects, or in general, any pipeline that is using data and that we're going to consume to do something about it and to actually affect that business use case in a positive way, that's where you actually generate value for the business. You may have a very, very different group of people interacting with what I call the artifacts of this data pipeline. And when we talk about artifacts, I'm going to just say, think about artifact 1, connecting to a data silo. Think about artifact 2, attaching 2 data tables or 3, concatenating data tables. Artifact 4 or 2, I need to clean this data. I need to create one formula so I can properly represent my business use case. What about artifact 5? I need to create a dashboard so I can describe my business use case with some visualizations and some descriptive analytics. And then what? And then what's going to happen with that use case? Well, usually you would like to push that into a descriptive analytics. And that's where you can interact with different machine learning algorithms to see if you can have a solution that is into the predictive side of the spectrum. And then if you think about how each of these artifacts were produced, you may have a very diverse set of things that are not necessarily integrated. So when we think about the data engineer connecting to that silo, and then we think about the business SME that is actually evaluating that model. And then you think about the risk manager thinking, is that model doing what we think is doing? And then you have maybe somebody for IT operations. Hey, how I monitor this thing? Can I monitor the model and check for improvements? Or is this model still fitting our requirements? So today you see this is actually very broken. It's not a smooth communication. Why? Because these teams are not able to tech communicate when everybody is building that asset in a completely different way. What kind of way? Well, some of them are going to have coding skills and are very open source oriented and are reusing a lot of the very cool packages and libraries that we have out there in the coders community, which is phenomenal. But some of perhaps non-code background or skills, however, very good analytic skills and BI skills and descriptive analytics skills, right? So it doesn't make it better or worse, it's just complementary. So now we can all work as a team. Data science is a team sport. So at this stage, all of these broken pieces are not really communicating and is not a smooth process connecting your people, your process, and your technology. And if you think about this when you are scaling, you may have today a couple of models and think, okay, I have this use case, a machine learning algorithm that I'm going to deploy into production, and there are a couple of them. But tomorrow you may have more than a couple. And the day after tomorrow, you will have way more than a couple. And when you think about scaling, when you don't have a smooth process, you're going to have a lot of issues because you're going to keep scaling those issues, right? So we need to fix the base of that framework, which is how can we smooth out this process where we can have the entire analytics lifecycle from the beginning, from connecting to data sources, transforming that data the way that we need to represent in that use case, experimenting with machine learning, involving the SMEs, validating those machine learning models, and then deploy that into production for an extended team to benefit out of what we are building and assembling. So how are we going to connect all of these dots in the smoothest possible way? Well, what do we have in common when we say MLOps? what happens when you Google MLOps images, right? I see a very consistent pattern, that feedback, that loop. You need to ensure that whatever you are producing is part of a bigger framework. You need to ensure that that framework is as smooth as possible so you can actually think about scaling. And you need to ensure that your team can communicate and that they can reuse what they are assembling and building as artifacts, as we mentioned at the beginning. And that can be in very different ways. And that can be using different techniques and using different tools. So you may have open source, not open source, coders, no coders, but at the end, we are all trying to go into this loop that is going to improve what we are doing with data, that is going to smoothly connect our people, our processes, and our technology. But if we think about it, technology is a big component there. And what that means is that we all have a different infrastructure. Like if I invite everybody right here, right now, who is attending this session to think about where your data is today and where your data may be tomorrow, I guarantee you I will have many, many, many different answers. And this is what we are seeing in the industry today. So I'm going to explain the left side of this slide. The left side of this slide is representing that infrastructure. Where is your data living? What kind of compute resources do you have as part of that infrastructure? Where is your data today? But most importantly, where is going to be tomorrow? Because you don't want to assemble all of these processes, connecting all of these people for something that in a year is going to be completely irrelevant. So whatever solution you put in place, it has to be resilient to that change. It has to be future proof. It has to allow your team to keep collaborating and keep assembling those artifacts that are part of that analytics lifecycle in the way that they are used to. And when I say in the way that they are used to, it means it can be code.
Right. Looks like my screen is up. Can somebody just pop in the chat if they can hear me as the slides come up? Perfect. All right. So to kind of pick up where Catalina left off. So kind of talking about the idea that whatever platform you're going to use, whether it's purely open source, a mix of technologies, whatever it's going to be to support MLOps and doing the analytics work you're doing today, it needs to be flexible. It needs to be something that you can change as you go, right? So you can connect and use whatever data you have, also whatever compute you have. So as you're moving it through that iterative MLOps process, that things work smoothly, right? And so when you think about all the pieces of the puzzle, that's more in the middle. These are the kinds of things that support removing those frictions, right? So thinking around to be able to start and get business understanding and find data, I need visibility, cataloging, connectivity. I need to find ways to be able to, as I build out features, as I transform my data to make those things repeatable, shareable, and again, visible, right? So the pieces of the puzzle, these green boxes in the middle and the platforms that support it underneath. So thinking about centralized governance and audit, systemized reuse and collaboration, integration and staging. These are the general building blocks that start to help remove those frictions. And they're really important. And we're going to go into those in a little bit more detail now, right? So this is what we want it to look like so that we don't have those frictions, so that you can seamlessly iterate from finding data, preparing it, creating the features you need, making those features easily accessible by other people that need them. Of course, being able to do your model development, but doing it in a way so that when you need to iterate as the environments change, as you experience drift, you can easily do so. Make it easy to get into deployment, but not too easy, right? Having things like the right stakeholders being able to validate and give model sign-off, both from, let's say, the business perspective, but also from things like control and risk perspectives, because if you start to scale and you have not 5, like Catalina was saying, but 100 to 500 models in production, you need to have risk processes around it validate those risks, and then making it really easy to consume those models. Something I hear in the industry all the time is the part of the operations part that breaks down is when you have to actually put the business impact in the hands of the users that makes sense, whether that's an API feeding something like a customer service iPad app, or whether it's something more simple like batch scoring customer data over time. And then crucially, you have to have standardized ways to do model monitoring and do continuous improvement. And I think a key theme of what I also see in the industry is being able to flexibly and dynamically decide how human in the loop that model monitoring and continuous improvement should be. So thinking, when does it make sense to maybe kick off something like an automatic retrain for maybe a use case that, I don't know, is less risky, less customer facing? And when does it make sense to actually have it more of an alert system where the right data scientists or ML engineers are pulled in to investigate? And so what we're going to do now is we're going to go into each of these areas in a little more detail, highlight the pieces of the puzzle that need to be there. Some of this will be things that we definitely have. And these are all things we have in Dataiku, but obviously this is an agnostic idea where regardless of how you accomplish it, whether it's all in code or an amalgamation of technologies, these are the pieces of the puzzle you have to have. Once we've reviewed all those and seen them, I'll show you them in action, kind of what a day in the life of an MLOps process might look like for real in our platform. So when you start with prepare, right, what we want to show on these panes is, of course, when you think about preparing and transforming data, you as the data scientist have to be able to do these things, right? Especially for the ideas of like last mile transformations or feature engineering. But it's also important to keep in mind that, of course, like we've been highlighting, there are other people with other hats, right? Where the data engineer is worried about, are you the data scientist hitting the right sources? Are the pipelines they're setting up available to you in the right way? Whereas the business SME, right, wants to make sure that the content meets expectations, that you're doing things that are in line with what makes sense from a business perspective. So being able to connect the data wherever it lives, right? Extremely important. Having things like a catalog and feature store, things that have been talked about a lot in the industry, but can be difficult to pair together in different platforms. Even just simple things that no one likes to do, but projects and wikis that can help involve other personas easily who might not actually be doing something like building the model. And a piece from the focus side of things that really matters from the Dataiku perspective is the ability to, when you think about explaining and qualify projects, is to have that bird's eye view and a really easy place to bring in those different stakeholders. So think like my set of risk managers, where they don't need to see necessarily always your Python code or whatever way you've created your frameworks and your models. They need to understand the value, the risk, the feasibility of the project, and the key metrics that are helping decide when it goes into production and when it needs to be updated, for example. And then when we think about feature store means a lot of things to a lot of different people, right? But the main idea is you want to avoid reinventing the wheel, and you want to have the golden standard around what is the right business logic to include, and what is the baseline we want to use when we start doing a model, let's say on late payments, for example. Where do we start if I'm not a financial expert? And obviously the key underneath that is the idea of reuse and being able to rely on the data you're using. Right now, also from the other side, thinking about, is the model robust, secured, and approved? Is it safe and compliant to our policies? Lots of people in the mix that are supported by those actions. And this has to do more with the building, right? So obviously you guys are going to be building the model if you're the data scientist persona, but I'm sure if there are others amongst you, if you're thinking about the idea of your data science team, again, going from the 5 models they have in production today to the 15, you want to make sure that it not only meets policies, but that it's robust, right? That it's going to be able to handle the types of data that are coming in and give good results. So in this side, we're talking more about lots of different flexible ways to make this happen. So, on the building side, something like, do you have easy ways to really quickly prototype out simple models before you want to find the final version that's going to matter? You have versioning on everything. You have standardization around how you're going to do that versioning for your data, for your model artifacts, like Catalina was saying, and for the overall flow itself that you're doing, whether it's something like Airflow or MLflow or whatever's helping bring everything together. And then how do you set yourself up for future success? right? So how do you include guardrails and assertions around the work you do so that when maybe it's not you who has to look at this model and understand if it's valid or needs to be retrained, what are the breadcrumbs you can leave behind? Right? And that can be done in a lot of different ways, whether some of them are automated, some of them are custom to the case, including someone like a business SME, but really important to have those, especially as you think about in today's environment with the amount of turnover in the industry, right? Something I hear all the time is I have data scientists who made something phenomenal, right? But then if they leave or if they're assigned to other projects, we don't have the right people who can keep that up and allow them to keep doing the projects they want to. And this comes down to one of the key tenets I've seen a lot also is whatever your MLOps process is going to be, it really needs to work for all models. So not just models built in one platform, but models built using those open source libraries, whether you're using something like Scikit or something like TensorFlow, you have to be able to easily apply those standards to lots of different types of models and processes. Right. And then again, making sure you can control those with things like stress tests, assertions, and those built-in diagnostics, all really important. And then when we think about this side, right, how long does it take to get models into users' hands? And is it easy to deploy? Or the way I think about it is it the right amount of easy, right? The parts that should be being easy and the parts that should have the right sign-offs, having the right sign-offs. And this is, I would say, probably commonly the area I see as the one that causes the most pain with my customers. So when you think about how do you let people who want to focus on building models and analytic products focused on that, while letting the people that should be focused on deploying and monitoring focused on that. And obviously, depending on your maturity and your industry, you might be working on all of these steps, but allowing if you are the person to make that easy. And we'll definitely show this how the act of deploying, whether it's going to be batched or real time, can be made really seamless and standardized. So again, not making it too easy, that idea of model approval is going to be really important, whatever that process is going to be. So that you have clear validation rules and different stakeholders can document and share their thoughts on the process. And then also making sure you have that central point for deployment, whether it's batched or real time, and making sure that when you're pushing it into production, it's going to run just the way it did in development. So then on the last piece of the puzzle, it's really about, can we monitor, right? Does it still fit our requirements? Because as you all know, in the moment you've made a model, it's going to start getting worse in almost all cases, right? Because we're working with stale data once we train it, once things are coming through. So of course, getting it up into an area where it's producing results is only half the battle. And so this is where, and I see a lot of different things across the industry. I see everything from, the idea of I check a dashboard when I feel like it's necessary. And that might work for some use cases that aren't quite as critical, but trying to provide an area where we can both support those less critical use cases, but also make sure that all the way up through automated alerting, automated retrain, being able to analyze seamlessly data drift, model drift, comparing models across time, and making sure that you can make the right decisions on how to do that sort of continuous improvement. So that comes from how you can audit everything and what kind of built-in things do you have to aid you, or if you're doing everything in custom code, how do you make sure you share those reusable blocks so that it's used in common across the organization, being able to compare those things over time. Also things like how do we automate this whole piece of the puzzle, right? How much glue code do we have to write to integrate with our scheduler and our things that kick everything off? And really the whole goal is to make it an open ecosystem so that at any point you can export, run things on the edge, or do anything that's necessary. So with all of that said, what I really want to walk you all through next is kind of bring this together, because I think sometimes when you hear all of this, you're all thinking of your different processes, how you do things, kind of how does this tie into this sort of multi-persona collaborative framework? And so when we've been giving this presentation, I think what's really started to tie it all together is to go through an actual example and show you how this could look day in the life. So bringing up a use case I think we should all be familiar with this fictional Acme Inc. company, the idea of credit card fraud, right? So I'm sure you guys have all experienced this, go and swipe your credit card somewhere, that hits a live API endpoint in the background. If it does look like fraud based on your previous purchases, demographics, geography, you're going to get that text that you have to identify whether that's fraud or not. And this organization, Acme Inc., has had a lot of trouble doing these sorts of important use cases because they don't know if they have low performing models when they do create them. It's really hard to avoid reinventing the wheel and finding analytic assets. And as they've tried to go from, we have one successful model in production that's creating business impact to 5 to 10 to 50, there really aren't enough processes to limit the risk around it. Too much time is spent on maintenance. So I want to introduce 3 personas. And as we go through this example, I'll be putting on the hat, kind of bouncing back and forth between Jim, Helena, and Katie to help this make sense. And just to help you get familiar, and so you might be able to match them up to personas that you're familiar with in your world. Jim's the business expert. And for him, machine learning analytics really just comes down to how he can scale revenue, manage costs, and really what he's worried about as he hears his organization, Acme, going more into this is that, well, what about if the right things aren't in place because I don't understand it? I'm worried about the business getting brutally hurt, right? Because it's not something that he feels comfortable being able to understand whether it makes sense for this to go into production or not. We got the data scientist, Helena, who's obviously more focused on delivering more efficiently. Where can I find reuse? How can I get more things out the door? But it's hard to get new members to onboard, and it's hard to build and deploy at speed to really get that dichotomy. And then we have Katie, she's an ML, call her an ML operator here. It could be an ML engineer, whatever you might call it, your organization. But really, it's her goal is to control and monitor models, more focused on the streamlining the life cycle than building models herself. And her pains are that there's just no big picture for her to feel comfortable for one place for her to make sure that things are running smoothly. So this is kind of before they approached MLOps in this removing friction process that we've been highlighting throughout the presentation. But what I'm going to show you now is how this can look different. And we're going to assume there's a use case, this credit card use case. Q1 last year, they actually decided to build a model. And they decided to make sure that as they built it and set things up, they were pursuing this frictionless MLOps framework. And so it's now Q1 of the following year. And each quarter of last year, they were collecting ground truth to get that feedback loop. So think the idea, I get my credit card statement from Acme, and I tell them that, these 3 transactions were fraud, and they're feeding that back into their model to evaluate how good the predictions were, right? So Q1, the model's now been in production for 1 year, collecting that ground truth. And we're going to put on the hat of our business expert, Jim, to start things off. So Jim comes back from lunch, and what Jim sees as he's going into kind of his familiar applications on his computer, he's in Slack, and he's actually just gotten one of these automated alerts where he's getting a drift warning related to one of his projects that he can then easily link to. And this is important because Jim needs to know exactly where to go. He kind of needs to be kicked off because it's not like he's going to be checking his models daily as models associated with his business daily, since he's the business expert. So Jim is going to hop here into this project. And this whole project, this is lining out the life cycle of this credit card fraud use case. It has all the pieces that Catalina was highlighting in the beginning, from data connection to model training, evaluation monitoring, scoring, all these things. But really nothing on the right side here really matters to Jim. He might have had some impact on what data sources to look at or whether the business logic makes sense for some of the feature engineering. But this is really out of his depth. But fortunately, linked right to the same area in the same place, Jim can come and get an idea of what's going on in a dashboard. And these dashboards can serve all types of purposes throughout those stages of the cycle. For example, this first page can help with model validation. So Jim can kind of see if a data scientist on his team makes sense easily and visually. But today, based on that alert, Jim is going to head to a more business-oriented dashboard, right? Where instead of things like rock scores and precision, he's seeing total missed fraudulent dollars and percent missed fraudulent dollars going up over time. And this does make sense to him. This is his core business he works on. And because of this, he's going to then reach out to Katie, that ML engineer, that ML operator, and let her know that he's seeing some troubling things in the business, and he'd really like her to take charge and start investigating what needs to be done. Does this need to be remediated? Do we need to take down the model? What do we need to do to make sure that we can avoid this trend line continuing? And Katie says, thanks. I appreciate that. I'll move that to the top of the priority list. I was already investigating it because I had my own alert. But Katie's not going to be coming here to look at this individual project. That's really not where she focuses. Katie is going to live in more of that centralized watchtower, right? Because she wants that big picture. She wants to be able to see things like a model and an analytic artifact registry, where she can see how things are drifting, what's happening, and not just that, but also see how they relate to things like business projects and initiatives, right? To really give her the context necessary to decide to maybe assign a data scientist to investigate this further. So she's going to go ahead and find that particular project that she got an alert on that Jim told her to move up in the priority list. And she can really easily see, all right, here's the project. Here's the active model in production. And if she wants to get some more context, she can dive in and see a lot of the things that you'd expect to want to see to understand what's happening. That the data is drifting, right? The data that was used to train the model is significantly different, it appears, from the data that's coming in today in that last Q4. That things like accuracy are dipping and that things like precision are dipping. So starting to give her some ideas that this model doesn't seem to be looking so good. But instead of just ringing the alarm bell and saying, hey, Helena, can you take a look at this, or whatever data scientist she has, she's going to get some extra context on this project. And this is the sort of context that is really important to make decisions. Just even high-level descriptions of what this is, who's the ultimate sponsor to understand how this matters. See things like who are the sign-off reviewers and approver across different stakeholders. Even starting to see things like, okay, getting the context that this was started last year and how it's moved through the stages like exploration, qualification, and the different documentation we have along the way, easy for review. So the idea here is that everyone kind of has their place to be able to find the information they need, and this can give Katie the context she needs to pull in that data scientist. And she's going to pull in Helena. And I think a really important thing to note here, and this is where things can get really difficult in the real world, is that Helena's probably not the data scientist that created this initial pipeline, that created this initial model that both has that live API endpoint and that batch score ground truth feedback loop being fed through it. But fortunately, she has a lot of things to kind of help her get there. So she has things like this model documentation that are already archived, so she can see, understand helpful information like, predicted predictions, calibration charts, things like variable importance to get an idea of what she's looking at. But crucially, beyond the documentation, that data scientist can just hop over to that ground truth feedback loop area and say, great, here's that data coming in from customers as they mark things as fraud, for example, or as our fraud investigation team has determined things are fraud. And it's really easy to seamlessly apply that against the model in production so that she can start doing an actual investigation on what needs to happen. And that idea of continuous improvement, what needs to happen here. And these are similar charts that Katie saw, but now Helena can actually dive in. So this bottom line here represents the drift accuracy F1 score of the latest ground truth data. And there's a lot of information here that Helena can investigate. And because she saw that data drift increasing so precipitously, she's going to go ahead and run this data drift analysis, which is actually running a random forest classifier in the background to help determine the difference between the train time data in Q1 of last year and the latest ground truth data in Q4. And she's seeing that in this case, anything above 0.5 indicates drift. So she wants to do a little bit of a deeper dive. And she can even go feature by feature and see something like, if she looks at the current distribution of that ground truth versus the orange reference, we can see that the current data is shifted pretty far to the left in card age. Could be that we have a bunch of new people signing up that have a different sort of, profile spending habits than what the company has had in the past. Can even see things like if we compare the original model feature importance on the y-axis to the drift model feature importance on the x-axis, that something like card age has really drifted a lot. It's important in determining the difference, but was, of medium importance in the original model, where something like merchant subsector description is a little bit less important for drift, but extremely important in the original model. And what we've seen a lot in these cases is that these sorts of breadcrumbs, being able to look at this is extremely helpful for Helena, the data scientist, to start making decisions and start doing new experiments, but is also really important when you want to get validation back from your business SMEs on why you're doing what you're doing. Before she starts looking to make some changes and decide what to do, Helen is also going to check out this prediction drift, where she can see helpful things like, hey, in my reference data, about 5 in 1,000 were predicted fraud, where in the current data, only 1 is. Maybe get a little bit of a deeper dive by looking at those predicted probability density charts. So overall, business SME has signaled to the ML engineer, did some research, got the data scientist involved, done some important input data and prediction drift analysis. Now we've got some context to help us actually make some changes back in our dev environment. So if we take a look at this, and I'll just highlight here that this is a case where we see this as a mission critical use case. So we're really going to automate the alerts versus automate things like retrain. But everything that Helen is doing to potentially, analyze these things, set up custom thresholds, and then kick off, let's say, retrain and redeploys, that can also, obviously, in many MLOps cases, be fully automated. Really depends on the use case. We're just focusing on more of the human in the loop scenario in this case. So Helena could maybe try to create some new features, bring in some new data to enrich things to improve. She could also go back to her original analysis or her colleague's original analysis and try to create new experiments, new sessions, create things like incorporate new custom algorithms, whatever makes sense. Once she created those, she could get a lot more information on things like, how did that variable importance work? How did things like everything else tie in together? But today, based on what she's seeing, she's going to make sure the latest Q4 data is fed to the model and initiate a retrain. Now, just to save ourselves some time here, I've already done that retrain. And Helena can quickly come in and see, all right, so here is the active version of the model, version 2. Here, version 3 is that retrained version of the model. We can see that based on those dropping metrics, our ROC score is back up to 0.705, so it's giving her some confidence. But really, she's going to have to do a little more analysis before she feels comfortable trying to deploy this. Of course, more validation. And here's where we can start to look at things like maybe even subpopulation analysis, individual explanations that can help us give a lot of information on whether we have biases in the model we're not expecting, for example. We can also highlight both automated and custom-made sorts of guardrails that are put in place. And this is really important, especially because Helena was not the original creator. So things like automated generated checks, letting you know you have an imbalanced data set, looking for things like overfit and leakage so that Helena can say, I don't even have to worry about these things. There's nothing to report. So I know that's looking good. And on the idea of custom guardrails, we can set up things like, hey, look, if the card age is above 85 months, we expect the vast majority of what we're getting in to be non-fraudulent transactions. Another really important collaboration point with the business where you can easily apply business logic to what we expect so that when these things go green or red, Helena knows she might need to either go back and make some more changes and investigate, contact the business, or she can feel more confident about looking to push to production. So with all this information, Helena is feeling pretty good. So she's going to go ahead and choose that she wants to make this new retrain model version active. But of course, this is now only active in the dev environment. So how do we now think about how we work towards the actual deployment? And how do we make sure we right-size the effort associated with it? Well, in this case, once this is set, Helena can both update the ground truth automated pipeline through a bundle that includes all of the code environments, all of the necessary connections to the data, everything that's necessary to do that, and publish it to a deployer, an area almost like a way station where a different persona can potentially push between things like dev, test, and production, or set up things like A/B testing, champion challenger scenarios. She can do a similar thing with that live API endpoint, which is now pointed at the latest version of that model, and we can then republish to that same area. Now, this could be, depending on your organization, where Helena's story ends, right? Maybe an alert now goes off back to Katie, that ML engineer, or it could be her. It really depends upon the organization. But regardless, this is that deployer area where I can see in this case that version 2 of that API is what's currently deployed in production, let's say. And if Helena or Katie, whoever it might be, wanted to deploy that, typically, obviously not straight into production, but typically more into something like a champion challenger scenario, we could do that, but we're going to get these governance halts based upon what Acme Inc. has put in place for their governance standards. So in this case, can't push to production until we get the right sign-offs and approvals, where Helena might need to go back to where she just created this new model, retrained, and do something like produce our automated flow and model documentation. And then bring that back to that centralized model watchtower so that she can get that sign off for her model. We're in this model within the project. We can see here's our version 2 already in production. And then we have that version 3 retrain, which is still sitting in development. So Helena could come in, upload that supporting documentation, and request the proper sign-off from all the stakeholders, IT and operations, risk and compliance, and the business, maybe her own colleagues. Once that approval's all granted and she's followed that framework, we can come back here and push that option seamlessly to a shadow production, whatever makes sense. So I hope kind of seeing all of these steps, I know it's a little fast, but want to make sure we can show you the whole process of kind of an MLOps journey. But hopefully this has started to make it, a little more real, right? Where you can start to see how all of these different personas can work together to solve all the sorts of problems and the frictions that Catalina was highlighting in the beginning part of the conversation. So from that business SME, Jim, to the ML engineer, to the senior data scientist, when you approach MLOps with all the personas in mind, right, it's way easier to identify when models are degrading, to investigate potential solutions once you see the models degrading, and then also rapidly update models in production, right? But all wrapped up crucially in that, safe governance framework. So, this is kind of what we're trying to get to, right? We need to turn MLOps into a team sport. It's not just about how do I push something into production once I've created it. It really is all the way through the process. It's how you do that preparation, transformation, business understanding, discovery, how you do actually build those pipelines, create the models that make sense, get that sign off so it can get into the deployment and be consumed. And then again, making sure that we understand that's just the beginning of another loop where we have to set up that monitoring, do that continuous improvement, and bring us all the way back through the process. So with that, thank you guys so much for sticking with us as we got through some of those technical difficulties. We've got about 10 minutes left. I'd love to open it up to questions, and I've got my chat up. And I think we've got Catalina back on, so she can add some context as well based on questions. Or if you have anything else to add, Catalina, feel free.
You did a phenomenal job. And I think that's the moral of the story, guys, here. How are we going to smooth out those processes? How are we going to connect our people? How are we going to ensure we can reuse these artifacts so we can actually scale? How are we going to think bigger? And thinking bigger means having the whole framework in your mind and ensuring that an extended team can tech collaborate and reuse these pieces and components. And that's part of the framework that we wanted to share with you today. There is a lot, and as any analyst pipeline, right, there is a lot of stages and there is a lot of work that happens behind the scenes. But we are all very proud of being data scientists and analysts and being able to use this data and reuse it and use these assets and reuse them and ensure that we can tech collaborate so we can actually scale and we can think bigger. Share your questions, comments. I am sorry about the Wi-Fi issues. I am in a hotel in the middle of nowhere and we kind of anticipated that, but I'm very sorry about it. I'm so thankful that Chris was part of this. Questions, comments, just can do it in the chat. If nothing, great seeing you all virtually. And hopefully we were able to share a couple of things that you find useful for your journey.
So I've seen your question on the AI Infra Alliance landscape. I'm not sure. I don't think we are currently involved with that process now, that their kind of stack of machine learning, but it's a good thing to bring up that we can bring back to our product team as something that people are interested in. All right, well, if nothing else, thank you guys again so much. Japa, let us know if there's anything we need to do. Otherwise, we can hop off.
Hi, Chris. If there are no questions, you can hop off the.
Great. Thanks, everybody. Have a great rest of the conference.
Okay.